So welcome everyone. This time everything works perfectly. And again, thank you for all the help. I'm really excited to be here. So today we are going to dive into the chaos of defending cloud-native environments. As I mentioned before, SOC teams really have troubles when they try to investigate cloud-native threats. And my goal today is show you why exactly it's so challenging. So we will start that by saying we already know by this time that Kubernetes clusters are a prime target for attackers, whether it's for exploiting vulnerabilities or misconfiguration. We're seeing it in Selenium grid servers, Apache NiFi instances. Those are just a small fraction of what we are seeing in the wild. Threat attackers successfully manage to exploit these vulnerabilities for their malicious actions. And what's really concerning is that vulnerabilities have now surpassed misconfiguration as the ~1 entry point for attackers in cloud-native environments. And it's even more concerning that it's happening with applications that are shipped with out-of-the-box misconfiguration, which means that attackers could exploit it once these clusters are live. And it's impacting all organizations, including Fortune 500 companies. And the window of risk is incredibly short. It takes less than 10 minutes to scan, discover, and exploit these newly deployed clusters. So the question is, how many of you today feel comfortable investigating these kind of threats? Because the reality is, whether we are comfortable or not, we need to be ready for that. A little bit about myself. My name is Daniel Davraev. I'm a product manager in Microsoft Defender for Cloud, specializing in Kubernetes and cloud-native threats. In my role, I work with engineering, security research, and customers to better understand how we can build defenses for the threats that we will show in this presentation. Early in my career, I started as a SOC analyst. So the SOC day-to-day is very familiar for me. I know the challenges and the struggle they have. And this is why I'm here today, to share those practical strategies, not just theory, but exactly how your organization could help your SIEM to become better at what they do. Here's our agenda for today. We will start with a quick Kubernetes 101, just to make sure we all speak the same language. After that, we will switch perspective. We see how attackers break in those Kubernetes services, and how SOC teams try to defend them. And then we will try to see how we can reduce the overall mean time to resolve, and we can wrap it all up with key takeaways and open it up for your questions. So for start, let's talk about Kubernetes. Kubernetes has become far from experimental technology. Today, over 80% of organizations already using it for deploy new applications. It's important to mention that with that adoption also comes complexity. We don't just have Kubernetes clusters. We also have managed services like AKS, EKS, GKE. We also have serverless platforms like AWS Fargate or Azure Container Apps, which sits on top of Kubernetes and abstract it even further. For security teams, it means constantly shifting attack surface. Oh, sorry. Just a second, it jumped. Constantly shifting attack surface. If we try to visualize what Kubernetes even looks like, it looks like basically this simple visualization. We have two main components. We have the control plane, and we have the data plane. We can think about the control plane as the brain. It schedules workloads, it maintains cluster state, it enforces policies. The data plane is where the actual workloads are being run in the nodes. If we zoom into these nodes, we can see the true complexity of Kubernetes. At first, we have the image. This image holds the application or even part of that application. What runs the image is a container. Container is run by pod. And that pod is managed by replica set, which then goes to be managed by a deployment. And it doesn't stop there. That deployment is part of a logical group that's called namespace, which is spread across the nodes in the cluster. This is the true hierarchy in Kubernetes. It's important to mention one replica set could run a group of pods, and each of those pods will run a container that also will run a specific image. That is the beauty of Kubernetes. Now, let's go back to our visualization. And now, as we mentioned, we are switching perspective. We think like attackers. At start, we take one of the most familiar use cases, compromised identity. With compromised identity, attackers could basically take out the entire clusters, and from there, he could spawn out pods, malicious pods, exfiltrate data, and so on. Basically do whatever he'd like. Another vector is the application level. Remember, those nodes, those Kubernetes clusters, are usually used for running applications, multiple applications, and many of them are public-facing. If one of the applications has vulnerability, an attacker could exploit it as an entry point for the cluster. We then move on to the environment misconfiguration, exponent management interfaces, or weak authentication or authorization controls to the Kubernetes API could mean an attacker could pretty easily take over the entire cluster. We then continue to another very important part, which is malicious images, vulnerable container images. If an application is built upon a malicious image or it contains an outdated exploitation, this could be another entry point for an attacker. Another option, as you can see, it's full of them, it's unauthorized traffic. Unauthorized traffic means that without proper network segmentation, without proper network segmentation, an insecure communication between pods or between pods to the outside world could mean an attacker could inject malicious traffic inside the cluster. If we take all this example, we can see that there's a lot of ways to inject into Kubernetes. Here's a specific example that was discovered by our security research team that shows how threat actors actually leverage those misconfigurations. In this specific case, the threat actors used a misconfiguration to take an app and turn it into a part of their infrastructure for a DDoS campaign. It all started with a misconfigured Java application. And JMX remote management misconfiguration was exposed to the public facing. That open door was all the attackers need to gain foothold in that application. From there, they spawned a bash shell from the Java process. Because that process was run as root permissions, they basically could run any command they would like. After that, they began to explore the system, see which identity they have, what permission do they have, and so on to better familiarize the environment. Then they started to clear everything that they have to impact the post-investigation of this incident. And only finally, they ran the Perl script, which connected to a known IRC server in Romania. This connection effectively enrolled these containers to be part of the botnet that they had. This means basically a healthcare app turned into a weapon against other workloads. The key takeaway here is that this wasn't a very sophisticated zero-day campaign or something like that, not at all. It was a simple misconfiguration left exposed, and within minutes, the attackers were already inside the cluster doing whatever they like and taking that cluster to be part of their infrastructure. When we look across the incident, one thing becomes clear. Attackers don't wait until runtime. They look for weaknesses across every chain in the software lifecycle. It starts at the code. We see malicious code injected into dependencies or open source libraries. This, with the knowledge that they know it will spread downstream. After that, we have the build stage. CI/CD pipelines are increasingly a target. Attackers try to poison those workflows, so they pushed without get detection. The next step is the ship. Once an image is built, attackers may change it if it's in a public registry, or or swap it with a malicious version, with the knowledge that if someone will download that image into production, they will have an easy access to that cluster. Next step is the deployment. Obviously, misconfiguration, such as weak permissions, over-permissive RBACs, exposed services, exposed secrets, these all leave the environment wide open for the attackers. And only finally, we get to the runtime stage. Even if everything else is perfect, which usually it doesn't, once the application is live and it has any vulnerabilities on its misconfiguration, attackers just leverage it to get foothold in the cluster. And once they're in, no matter what, it doesn't stop there. Whether they use it exposed pod or malicious image or anything else, they try to lateral movement for their prime target, whether attackers we see that want to expose sensitive information, get to a critical resource, and so on. This is exactly what we are seeing happening again and again in a lot of organizations. So far, we talked mainly about the attacker's perspective, how they get in, how they move laterally. But what about the SOC? How they respond to this kind of stuff? To be honest, when we talk about SOC playbooks, it stops at the cluster border. Analysts are well trained when it comes to phishing campaigns, to endpoint, to identity incidents. But when it comes to Kubernetes, they don't really know where to start. And the result we are seeing again and again is misclassification. We see true positive incidents that got labeled as false positive. Or even worse, we see incidents that started to get, the investigation starts, but then stops because the SOC team doesn't really know what to do next, and the attacker persists quietly. Let's understand the specific challenges that bring these up. So first of all, we need to understand how incident response lifecycle works. And it's pretty amazing. All organizations have usually 5 steps which effectively help them mitigate any threat in the organization. It usually starts in the triage. We can see in the triage that the SOC analyst team usually go through a queue of alerts or incidents, whether it's in their SIEM, in their XDR, or any other internal portal that they are using. Based on the queue of the alert, they then prioritize, see what's more important, what has more impact, what has critical severity. And from that, they start initial assessment. They try to understand if they have a true positive or a false positive. If it's a true positive, only then they start to see how they can contain the threat. First of all, to contain it. They don't want that threat to spread across the environment. Once they successfully contain the threat, only then they start to fully investigate what happened, how it started, what the attacker touched, which asset got exposed, and so on. When they have the full story, the full scope of the attack, then we have the remediation steps. The remediation step. Basically what it means, they want the environment to get back to the normal state prior the attack happened. They're usually deleting files, reset user passwords, maybe deleting some assets that were related to the attackers, and so on. Once the remediation phase is complete, it means that the environment is back to normal, back to the safe state that it prior the attack. And in that moment, usually what SOC teams do, they generate a very detailed report for the organization, which tells precisely what happened and how with all the timelines. Only then the organization takes that report and try to use it as from its lesson learned to prevent further attacks for being something similar. While this life cycle is well established, we still have some challenges when we talk about cloud native. Those challenges are stuck with the lack of context. I think most of you already know that. When we talk about the cloud, SOC team need to have all the context in the world that could help them to investigate the threat as best as they could. It doesn't stop there. Another key issue is that the complex hierarchical structures that the cloud has in any point of it, Maybe Kubernetes is one aspect, but we can see it in AI models, we can see it in storage accounts, we can see it in a lot of places. Next is the ephemeral and dynamic nature of the cloud. It's very unlike what we used to endpoint or the identity. In the cloud, in most cases, while the SOC team start the investigation, the data is already gone. Containers are short-lived. The storage account might get deleted. That VM is already deleted by the attacker. So it's important to see how we try to get into that challenge. And last but not least, the knowledge gaps. As we mentioned, SOC team has deep expertise in endpoint and identity, but when it comes to Kubernetes or cloud native, they don't really have that confidence. So what it feels like when they have really Kubernetes incident, exactly like this. They don't really know what to do. Maybe they should contain the pod, but who knows, that might affect a business critical application. Or they should keep it as it is. Hopefully, the attacker won't do much, maybe just a crypto miner, and let the attacker persist. Let's try to break each of those challenges down and see how we can fix them. So the first one, which is the biggest one, I believe, is the lack of context. Think about it for a second. SOC teams get an alert. Suspicious activity on pod XYZ. Cool. Now let's imagine even further. They have all the logs in the world. They all have all the process tree, the networking events, file system, whatever they like, they have. The real issue is that they still have a lot of unanswered questions, like who owns this workload? What team it's related to? Is it how long it has been running? And a lot of more questions. These are important questions that without them, the SOC team really don't know how to start this investigation. Some of you might ask yourself right now, okay, but what's really the big deal? Maybe he just needs to call the workload owner, and from there, he will tell him everything you'd like to know, like if it's important or not. And that's an issue of itself. It's not that easy to find the right workload owner. The reason for that is that, first of all, multiple teams deploy into the same cluster. So who owns that specific part of it? Another case, we need to remember that in most cases, those clusters are deployed by CI/CD pipelines, not humans. So there is no human in the loop to even call with. And moreover, those workloads are used by Helm charts or other third-party templates without a consistent tagging and annotations. So it's really, you can understand now, it's really challenging to find the right person to contact with. And what the SOC teams do, they just text in the Slack channel, hey, anyone knows who that cluster is? Or sending email to find the workload owner. Everything except investigate a threat. The second challenge that we talked about is the complexity of Kubernetes itself. As we mentioned, we have a threat, we have an alert on a suspicious pod. Great. But what about the other aspects of that cluster? As we have seen, pods are part of replica set, which are part of deployments, and it goes on and on and on. So when SOC team investigate, he needs to know that this specific pod has another pod, pod A, pod B, for example. It's really important because while we think we can contain pod A, attacker could just exploit pod B. And when we think about containment, I think in other domains, it's pretty easy and straightforward. Let's take an identity. Any guesses how we contain a compromised identity within minutes? We just disable the user, right? Perfect. Let's move to device. What we do with a compromised device? We isolate it. And file, we quarantine it, right? Anyone has an idea what is the equivalent one-click action for Kubernetes cluster? Like, what do we need to do? So first, let's start with the basics. About 50% of the clusters today don't have any network plugin enabled. This means you can't enforce network policies, that means you can't isolate any part of that cluster, which is a problem by itself. But let's imagine we have the plugin. Let's say we have the plugin. So what we are doing now, do you isolate the pod? But a new pod might respawn, or an attacker could exploit a different one. OK, So let's isolate the workload, which is the group of nodes, the replica set, for example, the deployment. But then there is a risk. You might now just put down your entire business. And let's just assume that the SOC has these tools, right? Because surprisingly, they almost have any of them. When we move to the investigation phase, and which we mentioned prior, we have another unique challenge, which is the ephemeral workloads. In Kubernetes, in containers, almost half of the containers live less than a minute. It means by the time SOC analyst even opens the incident, the container alongside with the data and the evidence is no longer there. That's why it's crucial to collect those logs in real time. We talk about process events to understand what was executed. Networking, and when I mean networking, I mean every networking log, such as DNS, API logs, HTTP requests, and so on. File system, which file was changed, which file was deleted, and so on. And last but not least, kube audit logs, Kubernetes audit logs. We want to see API logs, and so on. These are all important when SOC team investigate. Okay, so we walked through the challenges. We have clear understanding that Kubernetes is complex. We don't have the right tools, maybe. We don't have the context. So the question is, what can we do about it? The next session is full of practical strategies that could help your teams to investigate better those kind of threats. We will start with one of the most fastest way to reduce the MTTR, which is context. And the good news is that I've seen already organizations implementing those things through the CI/CD pipelines. They add tags like who owns this workload, is it critical or not, which environment it runs, whether it's pro, dev, stage, and most importantly, how critical is it to the business. If you're not doing this yet, you definitely should. The next is we need to modernize our playbooks. And when I mean modernize a playbook, here's a concrete example. Let's imagine that we have an alert, a binary drift alert. A binary drift alert basically means an executable is being run in the container that it wasn't part of that image. Pretty weird, because containers should run very specific executables. Okay, perfect. What we are doing from here, maybe the first thing I would do is check if it's exposed to the internet. If it is exposed, that's high risk, right? We want to contain it as fast as possible. But if it's not, that means it's internal. Maybe we should check out for lateral movement and something like that. From there, maybe we could ask what spawned this pod. Whether it's a deployment, then we can go to check the CI/CD. Maybe we deployed a malicious image. Or if it's a direct API, maybe we can check which service account interacted, or users, maybe we have a malicious users. And from there, we need to go back to tie it all up to the root cause. What was actually happened? Maybe it was a misconfigured app. Maybe it was a compromised identity, and so on. Obviously, this is a very simplified version, but the idea here that we need to make sure this SOC team has a very concrete plan when they have any kind of alert in Kubernetes. Because as you can see, a simple binary drift alert has a lot of branches that it could go through. Now, obviously, for the SOC team to successfully go through playbooks, they need to understand what the environment they are applied to. Organizations need to provide cloud-native IR training. And not only that, they also need to do a PT testing, make sure that SOC is involved. And it won't be the first time ever that the SOC team investigate alert as the real threat. That's the last thing you want to have. If SOC team will be practiced, he will have a lot of confidence in the action he should take when he encounters these kind of alerts. But even if they're well-trained, we need to remember that we need to provide them the right tools for the job. SOC team should have tools like block a malicious image from being deployed again, have an isolation capabilities, whether on a pod, it should be on granular level, whether pod, workload, and so on. We also seen response action like live response to the pod that they could actually go into the pod and run commands in it. Basically, what we're trying to say that you need to make sure that your SOC team has the tools, and it's not only the tools that they are stuck somewhere, but it's actually integrated to their workflow, whether it's your SIEM or XDR. And finally, and this is, I think, one of the most important key here, is that we need to make sure we define the risk boundaries, so the SOC team know where to draw the line. It's important to mention, not every workload created equally. Some workloads are much more critical for your organization, and you want to make sure that the actions that you are taking on it are we are very cautious about them. This is a simple pyramid that I created just to mention that, for example, what we call something green is like dev or test, something that we don't really care about if we isolate it or not, if we break it or not. Internal apps are something that we might think, again, maybe we need approval to do any action about it. But production servers and critical business applications are very, very important, and they should treat accordingly. We actually have seen an organization that have a malicious, for example, crypto mining running inside one of their critical infrastructure. And we asked them, okay, why don't you take any action? Why don't you do anything to remove that? And they said, the risk is too big. We will do it in one of our maintenance programs, but not right now, because the crypto mining will not impact as much as if that service will be down for even 1 hour or 10 minutes. And this is a very smart decision that they are doing. So you need to make sure that your organization knows which workloads should define those risks. If we summarize it all up, if we put it all together, reducing the MTTR is not a one-step magic solution. It's a combination of multiple things. We need to start with context, make sure we collect all the information for our SOC team to take action accordingly. We need to make sure they have the data to investigate, so we need to have real-time visibility. Then we need to make sure we also provide the right playbook so they could take action with confidence. We need to train them for the different scenarios that they have. And last but not least, we need to make sure that they also know where to cut the line. These specific assets are very critical for the business. We should not touch them at any part. Only after that, if we combine it all together, we can transform our entire incident response process for the cloud native entirely and reduce it. So, for our key takeaways here, attackers are already targeting Kubernetes clusters. It has become one of the biggest attack surfaces that we are seeing, and they are leveraging it. The next is we need to build SOC confidence by providing expertise to triage cloud-native threats. After that, we need to make sure we evolve our playbooks to support these kind of scenarios. And last but not least, we need to remember, reducing MTTR is not about speed, it's about resilience. We need to give the SOC the right tools, the right context to make sure they have everything that they need to investigate those kind of threats. And for that, I want to thank you all for your time, and I will open it up for your questions.
First of all, I want to thank you not only for your very, very interesting presentation, but also for your for the time that it took for your patience.
A lot of challenges.
I'm deeply sorry about the technical issues.
It was fine.
Deeply sorry.
Happens.
But now we do have some time for you and your questions. Does anybody have a question he wants an answer to? Yes, I will throw the cube. Sorry, way too short.
Coming back to one of your slides where we said about the one-click containment action we had for users, we had for devices. I think your presentation, or you wanted to show what is the one-click containment solution for Kubernetes, but I understood there is not a single one, right?
Exactly. Yeah, it's not that simple. Kubernetes, as we have seen, holds a lot of critical applications. So it's not like if you see alert X, let's immediately start and contain that Kubernetes cluster. It's not that simple, because I always tell to my engineers, imagine that Walmart.com will be down for 10 minutes. Imagine the financial impact of that for Walmart and for everyone, basically. So to respond correctly to Kubernetes kind of threats, you need to deliver those playbooks and understand, okay, if this is the cluster that we are speaking, maybe we can take this specific action or this specific action. If this is the namespace, namespaces usually are grouped of teams, like this namespace is for finance, this namespace is for engineering, and so on. Maybe on this namespace, we can take any action that we want, but this we should be very cautious about. But the point of the presentation is to show that we need to make sure that the SOC team has the tools. For example, one tool that I think helped a lot of SOC is to quarantine an image from being redeployed again. We have seen the possibility that some images are being quarantined in the registry, so the organization, the engineers, which are not usually aware that something malicious is happening right now, couldn't use that same image again. Is that help to your question?
Yes, definitely, but I think all of this comes back to one of your first challenges, which is context, right? I can quarantine whatever image I want as long as this is not transferred to the respective application team, DevOps team, whatever, it's not going to get solved.
Exactly, yes, on point.
So any more questions? Also in the back, I can throw really far, I promise. All right. Then there's nothing more to say. Then if you have any questions throughout the day, you can ask Daniel on a one-on-one basis. You will be here today and tomorrow as well? Perfect. You can use the dinner tonight maybe even. Or you can use the next break that is up. Before I leave you into the break, I want you to take out your phones, open the app, and rate this young man out of 5 stars. And then during the break, you can go into the lounge that is right behind us. So I want you all to use the left side door to exit and go to get your coffee through the lounge, because there will be a little presentation by our partner Tech Racer. So, but right now it is my honor to say thank you to you.
Thank you very much.
You did an amazing job.
It was a pleasure.
And a lot of thank you for your patience.
Of course.
Everybody clap your hands for this moment.